Hello students of class 10th, welcome to our Classroom TV. In our last class we started our new chapter, chemical bonding. So in this chapter we are trying to find like how atom going to be neutral or stable by gaining or losing of electrons, because from our various atomic theories we have been trying to find like in which of the following cases an atom be trying to be stable or attains its stability by losing or either gaining electrons. So during which when you are trying to say go with the concept of losing and gaining of electrons, we purely depend on the concept of valence electrons, or which we say as valency, because valency or the valence electrons will explain the number of electrons present in its outermost shell, or which we say as outermost orbit, are called as valence electrons. So overall the stability of an atom depends the availability of valence electrons in their outermost shell as per octet rule, which we learnt in our previous class, like octet rule which need to be satisfied for each and every element, like when atom when it tries to attain stability by for which accounts for the 8 valence electrons in its outermost shell. So the number of available valence electrons is quite most important in such a way that atom need to be stable by attaining and trying to get the 8 valence electrons in its outermost shell. So this losing and gaining of electrons takes place in order to see that the atom need to attain its stability and try to attain 8 electrons in its valence shell, called as octet rule, which we have seen in our last class. So let's continue the concept of octet rule and let's move forward by a concept called as electronic theory of valence, which we say as which we also say as electron theory of valence, which was being proposed and was put forward by Lewis and Cossell. So already we have been learning the number of valence electrons which were been depicted or which were been presented, and they were been shown in the form of Lewis dot structures, where we are trying to represent those number of valence electrons per atom in form of a dot or either in form of a cross. So these Lewis dot structures will try to show or depict the number of available valence electrons per atom, and later the concept of that octet rule need to be represented and try to show the number of valence electrons present in its outermost shell either by losing or gaining of electrons by this theory called as electronic theory of valence, which was been put forward by Lewis and Cossell, which we are going to discuss it. And even we are going to see the first type of bonding, and basically we classified the chemical bondings into two types, basically like a covalent bond and ionic bond. And in our today's session we are going to see like what is ionic bond and how its formation takes place. So when you start with electronic theory of valence, so here it depends purely, this theory depends on the number of available valence electrons, and those valence electrons whichever we are going to count or take into consideration, it depends upon the number of available elements for each periodic table. Because like when we are trying to arrange the existing 118 elements in a periodic table, so during which these particular elements whichever are arranged in the groups, where we go with the number of valence electrons, which is nothing but the group number, which gives us clear indication that it's nothing but those are the number of available valence electrons, or per that particular group number indicates its valency of that group which we are learning here. So if you go with the concept of this valence theory which was given by Lewis and Cossell, in such cases we are trying to find, like you can see here, basically the 1A group, 2A group elements mostly of S block, 1A and 2A group elements of S block, and P block elements you can basically find here the 5th group, 6th group and 7th group, which is your 15th group, 16th group and 17th group. So basically this theory, electronic theory of valence, is basically put forward in the concept oriented base, where we are trying to find the metallic character and non-metallic character. Means as we know very well about metallic characters, those metals which exhibit electropositive character, which are electropositive in nature. So all metals has a capacity or tendency to give out electrons as they are electropositive in nature. In the same way, when you go for non-metals, as we know, non-metals being highly electronegative in nature, they has a tendency to gain the electrons. So here, as we have been really concentrating on the concept of losing and gaining of electrons, so basically in our periodic table we find the metals, basically of first two groups, the 1A group and 2A groups, which belongs to metals, has a capacity of giving out electrons. So the tendency or the ability of giving out electrons, which purely shows the metallic character, which we found those metals are electropositive in nature. So you can see the groups of 1, 2 and 3 groups, basically where you can find is giving us loose electrons. So plus 1, plus 2, plus 3. It's clearly shown that the plus 1 charge indicates that this particular group, the first group, has the tendency of giving out 1 electron, and that's the reason as they lose 1 electron, they carry a unipositive charge of plus 1. In the same way, when if you have been trying to go with second group, so in second group you can find the charges which you basically found where they have the tendency of give out 2 electrons from its outermost shell, where we go with the dipositive charge of plus 2. The same if you go basically for third group, where they has a tendency of giving out 3 electrons at a time in their valence outermost shell, and that capacity we are trying to give, and those are designated with third group. So basically, as I said, metals, as we are electropositive in nature, they have the tendency of giving off electrons, and once these electrons are given, as the electrons are lost by those atoms of those are found to be with plus charges, and once those electrons whichever are been given out are just gained by the non-metals. So as we basically say, the non-metals are electronegative in nature, which contains a negative charge. So you can see this negative charge indicates that this have gained the electron, so minus 3. So they have this fifth group elements, where we basically find they have gained 3 electrons at a time, which have been given out by the metals. So the losing and gaining of electrons basically depends on the metallic and non-metallic character, which we already discussed in a periodic table, because this metallic character and non-metallic character will purely depends on the availability of the valence electrons in their outermost shell or the orbit, which we are trying to define here. So you can see in the same way in the sixth group, where you can see they gain 2 electrons, and in the seventh group, which we call as halogens, and the 17th group gains 1 electron. And then you can even see there's a group which we call as 18th group, which we call as 0 group elements, inert gases and noble gases. They automatically attain magic octet. So we are saying magic octet here in the sense neither they lose the electron or neither they gain the electron. Without itself, they try to find that their outermost shell are filled with 8 electrons. So that's the reason we say the noble gases to call to be as a magic octet. Means without losing or gaining electrons, because here overall the concept where we are trying to learn from our valence theory by which was been given by Lewis and Cossel, like basically losing and gaining of electrons need to take place in order to see the atom need to be stable or electrically neutral. So in such cases, like when we are trying to say that when atom need to be electrically neutral or stable, definitely we need to see go with the metallic characters and non-metallic characters. So based on this metallic and non-metallic characters, the electrons whichever are given out are again taken by those non-metals and try to be stable, and thus atom is electrically neutral. But in case of noble gases, we find their valence electrons are almost filled with 8 electrons in their outermost shell or in their outermost orbit, and that's the reason we say that the particular group is found with no available valence electrons. That's the reason we say this group to be a 0 group elements, noble gases or inert gases. So that's the reason we say it's to be a magic octet. Means without being losing or gaining electron, they itself find to be with the weight valence electrons in their outermost shell or orbit. So this is how the basic what is an idea behind this electronic valence theory, where we try to attain stability and try to satisfy octet rule either by gaining or losing the electrons by considering the metallic properties and some of the metals and non-metals, where we try to see the capacity and tendency of losing and gaining electrons. Yes. The next comes, what is ionic bond? So basically we already defined a chemical bond. That's nothing but the force of attraction between the two atoms, which makes them with the force which allows them to held together, or which try to hold together with some type of strong forces of attraction between those two atoms, which makes those atoms, when they try to form a molecule, because as we know the group of atoms in turn form molecules. So these group of atoms whichever in turn form molecules, so first we need to see these atoms are being held with some kind of a bonding which we are seeing here, and that's kind of the forces which tries or which allows these atoms to hold together, and thus we define those kind of an existing and the type of a bonding which leads to hold these atoms as chemical bonding. So basically again we classified this chemical bonding into two types as ionic bond and covalent bond. So first we are going to discuss ionic bond in our today's session. So let's see what is ionic bond, how does it forms, and let's go with some examples. So what is ionic bond? So basically ionic bond is formed between atoms of two dissimilar elements. So like basically like in carbon compounds, we have seen different compounds and the large molecules gets associated with each other and try to lead in the bond formation. So during the bonding we have find the carbon atom, it just get links to the same atom also, either it being be a positively charged or a negatively charged. But here in case of ionic bonds, is an important condition or a criteria which we generally come across, where we find dissimilar elements. Means dissimilar elements in the sense, here you should see that the elements compulsorily need to be a positively charged element, a cation, or a negatively charged particle called an anion. Means a combination, means a particular molecule or a compound whichever gets associated with this kind of bonding, you need to see those kind of bondings are with dissimilar elements, one being a cation, one being an anion, where a cation need to be a positively charged particle and anion need to be a negatively charged particle, which you already know, like the group of charged particles called cations and group of negatively charged particles called anions. So the dissimilarity elements, whichever the dissimilar elements which you need to take, and those dissimilar elements whichever are being found due to transfer of electrons from one atom of one element to the other, and they are highly reactive metals like alkali metals of 1A group, and highly non-reactive metals and highly reactive non-metals like your halogens 7th group on left side and right side of the table. So as is basically we already just considered the same example. So as you can see now, as you move from left to right, basically, so you can find on the left side of your periodic table, you can find these groups 1A and 2A groups which belongs to your S block. And as you move from left to right of your periodic table, you can find your P block elements, basically which are your non-metals. So these are your non-metals which we basically found. That's the reason we say your P block elements are representative elements. So these representative elements whichever we found, because in those elements where we found the metals, non-metals and even the semi-metal, because the different characteristics properties of all the multi elements which we found is been found to be in your P block, because as we know S block is purely which belongs to only two metals, and even D blocks also are the transition metals which we basically say. But when you go to your P block elements, as they are being called as representative elements, so these representative elements are found to be consisting of metals, non-metals and semi-metals. So basically here, like as we have been saying, when you are learning the formation of ionic bond, we see the ionic bond formation takes place between two dissimilar elements, one being a positive ion called cations and one being a negative ion called anion. So the basic charges which we see, so from left side, so as you can see these are metals we try to show the positive electropositive character where they has a tendency to give out the electrons. So they lose the electrons, and in the same way non-metals has a positive shows electronegative character where they try to gain electrons. So you can see as per the group number, you can basically see your 5th group, which is nothing but 15th group, this is 16th and 17th group. Basically they gain the respective electrons. So as 15th group, you can see they gain 3 electrons, and 16th gains 2, and your 17th gains 1 electron. So basically you can see here like this plus 1 electrons are basically being 1A groups are going to be reacting with your 17th group. So as per the note which we have seen here, like you can see the highly reactive metals like your alkali metals of first A group, 1A group elements, basically they react with your highly reactive non-metals which are found to be existing in your 17th group, that's your halogens, which are situated at the right side of your periodic table. So here you are going to go as per the condition, as we have said, that there need to be a dissimilar elements, and the existing or the type of bonding which we find in these two dissimilar elements, where one being a positive charged particle, a cation, and one being a negatively charged or an anion. So basically you can find here all these are your first group elements are found to be with positive charges, and these positive charges, they basically react and they try to give out these electrons whichever are found to be found with their unipositive charges. They try to give off those electrons, and those electrons are acquired and gained by your uni-negative ions which are present in your 7th A group, or which we have the 17th group, which we call as halogens. So you can say like these are your highly metallic character properties which shows electropositive, which are electropositive in nature, and these highly electropositive elements try to give out the electrons, and those are acquired or those electrons are gained by highly electronegative elements which have been found in your 17th group element of our periodic table. So that's how ionic bond formation basically takes place. So let's see with examples and try to find like how these highly reactive metals like alkali metals and non-reactive metals like halogens react together to form your ionic bond, where we try to find the transfer of electrons. So basically simply we also define the ionic bond as transfer of electrons due to dissimilar elements or the irrespective of charges getting transferred. So here because one being a highly electropositive and one being a highly electronegative, so during which we try to find the transfer of electrons from a highly positive element to a highly negative electron, during which we are trying to find like how these bonds gets associated because of the dissimilar elements which contains an irrespective charges, although they are not been of the same charges, they are opposite charged particles. And basically if you compare with these ionic properties, ionic bond properties with that of covalent bond properties, you can find in covalent character it's just only a sharing of electrons. It can be with the same element or it can be with dissimilarity, but you can find there's only a mutual sharing of electrons which just leads to covalent bonds. But here when you go basically with ionic bond formation, you need to find compulsorily, you should see there's a transfer of electrons, that too with dissimilar elements, one being electropositive and one being an electronegative, that too highly electronegative and highly electropositive, and gaining and losing of electron takes place in order to see the atom need to be stable and electrical neutral by attaining that bond whichever gets associated with it, and that bond we are calling it as ionic bond here. So as we know, like generally elements of metals have tendency of losing electrons. So metals has capacity of losing electrons to attain octet in their valence shell. To attain octet, that is the most important criteria, and overall the overall aim and role of each and every elements of an atom need to be stable by losing or gaining electrons. So here we found the metals which has the tendency of losing electron to attain octet in their valence shell, and this property is called metallic character or electropositivity. It's called as metallic character or electropositivity, and elements with more electropositive character only can form cations. So whichever elements are found with the more electropositive character, and those more, whichever elements are found with this more electropositive character, we can form cations here. And basically, like non-metals like oxygen, fluorine and chlorine acquire electron configuration of elements of inert gases by gaining electrons, as we know. Because as we found, the non-metals being highly electronegative in nature, so they have tendency and capacity of gaining electrons here. So you can find those electrons gaining electrons, and this property is called non-metallic character, or which we also call as electronegativity of that particular element. And elements with more electronegativity character can form anions. So overall, what we conclude from this two is like highly electropositive character elements. Elements which show highly electropositive character can form cations, and elements which show more electronegative character can form anions. So basically, you can take the examples of metals. So all metals are found to be electropositive in nature, where they need to have they have the tendency of losing electron. Yes, they give the electrons, and whereas non-metals are electronegative in nature and they have the tendency of gaining the electrons here. Yes. So basically, you can see if an atom need to be neutral, so you need to lose the electrons or either gain the electrons. Suppose if it's losing the electrons, they are cations, which are positively charged species, which are found to be positive. Suppose for an electron need to be neutral, you need to see there's a loss of electrons either by acquiring a positive charge. So as you know, the positively charged elements has a tendency to give off electrons, and basically the elements which are nothing but the anions, which contains a negative charge, which are highly electronegative, basically which are highly electronegative, contains the negative charge and they try to gain electrons. So definitely the losing and gaining of electrons basically takes place in order to see an atom need to be a neutral or it need to be stable. And the next comes an example where you are trying to explain the formation of NaCl. So you are taking the example for ionic bond. So basically in this case, you are trying to make an highly electropositive metal, that's sodium, and highly electronegative non-metal, that's an element which is found to be chlorine. So as you know, sodium, so you need to go with the number of available valence electron in case of sodium and number of available valence electron in case of chlorine. So here, as sodium being highly electronegative, you can find it lose electrons. So as per the configuration, as you know, sodium configuration 11, so 1s2, 2s2, 2p6, 3s1. So as per shells, you can see this is your K shell, this is L and M shell. So you can find the outermost shell of sodium is found to be M shell with 1 electron. So your sodium contains 1 valence electron, and that particular 1 valence electron, as it's being sodium, so when sodium, once it gives out its electron, when it gives out the electron, basically once it's giving out the electrons, you can find it acquires the positive charge. So this electron is given out. So once 1 electron is given out, it acquires a positive charge. As it's being highly electropositive in nature, you can find there's a loss of electron. So when you go for your shells, like you can see first, as you know, K shell consists of 2. It can accommodate maximum of 2 electrons. Then when you go for L shell, you can find it accommodates 8 electrons. So as per configuration, in shell wise, as you can find atomic number of sodium as 11. So you can see 2, 8, 1. So this particular 1 electron which is it's given out, so you can see the positive charge, like how basically it acquires the charge here by giving out electron, and acquires a positive charge when an electron is given out. And you can see this is the M shell. So this M shell is acting as the outermost shell or the outermost orbit. This is the outermost orbit or outermost shell, which contains a 1 valence electron, and that particular one valence electron is given out, and you can see basically there is only K shell with 2 electrons and L shell with 8 electrons, and by this you can find an sodium atom try to be neutral by giving out one electron in its outermost shell and trying to acquire an positive charge which we call as unipositive charge here. In the same way, if you go for in the case of chlorine, then in the same way in chlorine atomic number it's 17. When you write the configuration 3p5. So you can see there's only 5 electrons, 5 valence electrons present in the outermost shell of chlorine atom. So it's required basically one more to complete its octet, isn't it? So here basically you can again go with the electronic structure or the Lewis dot structures, the representation where we are trying to show the number of available valence electrons. So you can see again in the shell as per your chlorine number 17. So when you are writing atomic number 17, when you go with the distribution of electrons as per the energy levels or shells in KML, K elements, you can find the distribution. So you can basically find here there's one more electron which need to be satisfied to attain its octet, where we need to see there are 8 electrons, the 8 valence electrons present in its outermost shell. So basically this is your K shell and L gets filled with 8, and you can find there are only the 7 electrons in the outermost shell, where M is acting as the outermost shell for the chlorine atom, and basically when it gains an electron, so you can see it gains the electron and it becomes a uni-negative ion by attaining or by accommodating the 8 electrons. So you can see basically that one electron which was given out is acquired or which was being gained by chlorine atom and trying to be stable by getting the available 8 electrons need to be filled with its 8 electron its outermost shell and trying to be stable by according to our octet rule. So this is how we basically you can find the formation of ionic bond between two dissimilar elements, like one being sodium and electropositive element and one being a chlorine anion and highly negative element. So during which you are trying to find the transfer of electrons, like one being trying to give out the electron, and once the electron is lost by a particular unipositive cation, and that particular ion is being gained by an uni-negative anion, and where we trying to show the losing and gaining of electron, and where we try to find the electron being stable by attaining a bond formation, and the bond which try to exist between these two is found to be ionic bond. Yes. Let's go for another example. It's MgC, magnesium chloride. So basically you know the formula of magnesium chloride. It's MgCl2. The one example we have done with sodium chloride NaCl, the other we need to go for MgCl2, magnesium chloride. So basically even for magnesium, as you know, it's being electropositive metal, belongs to second group, two-way group. So you can find the basic valency, it's found to be 2. The common valency or the common group number which we found basically in case of magnesium is found to be 2 here. So here when you go for the configuration according to the atomic number 12, you can distribute the distribution of electrons which we see in the case of magnesium. Again when you go for K shell, it's 2, 8 and 2. So you can see the number of valence electrons which are found in case of magnesium atom is with 2 valence electrons, where you can find basically in case of magnesium. So you can see like this is the case of magnesium, where this is your K shell, L and M. So you can see these 2 electrons, one electron to one chlorine atom, the other electron to one chlorine atom is been given out, and during which you can see there's a transfer of electrons which leads to ionic bond formation. The transfer of electrons leads to ionic bond formation. So in this ionic bond formation also, where we basically trying to find like the number of available valence electrons in their outermost shell, which is given out by an electropositive element, that's nothing but it's your cation, with the magnesium being an highly Magnesium being an highly highly positive electropositive element, it's try to give out these 2 electrons. So one electron is given to one chlorine atom, the other electron is given to one more chlorine atom. As we know, chlorine atom requires one electron in its outermost shell to complete its octet, to have its 8 valence electrons and try to be stable. So in that's the case, you can find the overall the magnesium, when it's try to give magnesium atom, when it's try to give out the 2 electrons, those 2 electrons are being satisfied by 2 chlorine atoms by gaining those electrons and trying to fill their outermost shell with 8 electrons and trying to be stable, and hence the atom is electrically neutral, and the compound whichever is so formed, this magnesium chloride, is an example of ionic bond formation. So you can basically see this one chlorine atom gets filled with 1 valence electron of 1 magnesium, where the magnesium gives out the 2 electrons. So in such cases where you can find the 1 electron of magnesium is given out to one chlorine atom, the other chlorine atom gets the other magnesium electron. So in this way, where basically we find the bond formation which takes place between 2 dissimilar elements of respective cations and anions, where one cation being a positively charged and the anion being a negatively charged ion. So the dissimilarities between the 2 elements which makes the transfer of electrons between them, and the bond which formation takes place between them, which tries to hold the atoms together in such cases, is defined as ionic bond. So we learned with 2 examples basically. One is sodium chloride and the other we took the example of magnesium chloride here. Yes. The same explanation of the formation of the magnesium chloride means the ionic bond formation which takes place basically we have done with the Lewis dot structure representation, and basically how the losing and gaining of electrons takes place, which we need to see here. So magnesium chloride is actually formed from elements magnesium and chlorine, and the bond formation which basically briefly which takes place with chemical equations you can see here. So first, as per the reaction, magnesium plus chlorine, 2 atoms of magnesium, it forms a magnesium chloride. So this whatever the compound whichever is formed, it gets associated with ionic bond. So this is an example for ionic bond formation where we are using magnesium chloride. So you can see cation formation and anion formation. So basically cations, as you know, the configuration of magnesium, the distribution of electrons as per shells, KLM, and basically you can find again in your K shell found with 2 electrons, L with 8, M with 2 electrons. So where M shell is acting as the outermost shell or outermost orbit for magnesium atom, and basically as you can find these 2 electrons are given out, which you can see, and these 2 electrons are acquired or gained by 2 chlorine atoms. So you can see it's only 7, and once those 2 electrons are acquired or gained by the 2 chlorine anions, and you can basically find the configuration where the outermost shell is filled with 8 electrons, which we call as octet, and thus in this way you can find the atoms trying to be stable by attaining their valence electrons in their outermost shell with this 8 electrons. So basically here you can find like how we have been trying to show the losing and gaining of electrons. So how magnesium loses the electron as being highly electropositive, and how chlorine try to gains those electrons or acquires those electrons as being highly negative. So that concept we are learning here, like where ionic bond formation basically takes place by transfer of electrons between 2 dissimilar elements of one being a cation and one being a anion, where we are trying to go with the number of examples. And these are the cases where you are even going to learn like this elements are what they try to attain the nearest noble gas configuration also, because we find in our representation of Lewis dot structures when we were learning, we find the new noble gases, or which we as inert gases, where basically they are found with the 8 valence electrons in their outermost shell, and they are being stable, and that's the reason as there are no available valence electrons in their outermost shell, that's the reason we say them as 0 group elements, because their valence electrons are found to be filled and there is no left out any of the valence, neither they gain or lose the electrons, and their valence is found to be 0. That's the reason we say them as 0 group elements also. So in some cases, like whenever we are trying to those atoms which are trying to lose or gain the electrons, in such cases also you are going to find like how these electrons trying to attain the nearest noble gas configuration also, when you are going to learn come to your higher classes. Yes. So here just the way of representing and how the losing and gaining of electrons basically takes place that you are learning in this concept here. The next comes how you are going to see the formation of the example of a sodium chloride, which we say as a face-centered cubic crystal. Means this is an NaCl crystal where you can find it's a cubic center, which basically a general bit which gets filled. So the same we are able to see a cubic lattice structure which we are seeing here, which is a crystal structure which gets surrounded with sodium cations and chlorine anions. So you can see all whatever the blue colored balls are surrounded by sodium cations, one being positively charged, and you can see the chlorine anions which are surrounded by this green wall. So here you can find the nearest neighbors to these chlorine ions are 6 sodium ions. So for each face-centered cubic lattice crystal you are going to find the associated chlorine ions are with 6 sodium ions. So in such cases also we are trying to find, like, because it's a face-centered cubic crystal structure, basically a sodium chloride which is your common salt which you call as sodium chloride. So where you can find the number of ions of opposite charge which surround a given ion of a given charge as its coordination number of that given ion. So basically here, like when you go for the sodium chloride crystals, because this is a face-centered cubic structure of sodium chloride which gets surrounded with the oppositely charged ions, which is nothing but your chlorine ions, which being in electronegative ions, they gets equally surrounds the positively charged cations which are acting as sodium here. So it's also an ionic bond example, because it's been also found with the face-centered cubic lattice crystal structure, where we find each of those ions gets surrounded by these ions, and those ions are being given with the coordination number which you will be learning in your coming higher classes. But basically here you are trying to find an structure, you are learning it with a which we call as, and trying to be with the NaCl, the sodium chloride will try to possess a face-centered cubic lattice crystal structure, and sodium chloride crystal where it contains a coordination number of sodium plus ion is 6 and chlorine is also found to be 6, because here equally you can find the number of ions which are found to be oppositely charged gets surround the gets surrounded by the positive charges. Means this equally the negative charges gets neutralizes, gets balances with the positively charges, where you are trying to show this in the form of a face-centered cubic crystal of sodium chloride structure, which is an example for ionic bond formation. Let's summarize like what we have done in case of ionic bond. So ionic bond is formed between the atoms of elements with electronegativity difference which is equal to a greater than 1.9. So we when you have been learning the periodic properties, so we learn an electronegativity as a periodic property which gives the arithmetic mean of ionization potential and electronegativity. So here electronegativity is going to give you the arithmetic mean of ionization potential and electron gain enthalpy, because in ionization energy concept we learn basically like an energy required to remove an electron. So yeah, as we know, like metals has the capacity, tendency to give off electrons. So when they are being removed from their outermost shell, we require minimum energy, and that minimum energy whichever is required we are taking as ionization energy or ionization potential, we have been defining it. And once this energy whichever is required to remove an electron, and once that electron whichever is removed, it's been gained or acquired by those ions which are non-metals, which we say as electronegative elements. So those electronegative elements has a tendency to gain these electrons, during which we see that when this electron is added, your energy is liberated or given out. That's the reason we say this electron gain enthalpy. So that's the reason you can see some of the factors whichever we basically learnt in our periodic properties also affects in case of ionic bond formation also. So what are those factors like basically which we learn? So because as we know the tendency of losing electrons, Basically, tendency of losing electrons is nothing but to form cations, and the gaining of electrons to form anions depends on the following factors. One is atomic size, again the same ionization potential, electron affinity, and electronegativity. Because here we already defined electron affinity is also called as electron gain enthalpy. It's defined as electron gain enthalpy. So this electron gain enthalpy is nothing but the minimum amount of energy which has been given out or liberated when electron is added. Because in case of ionization potential, or which we says ionization energy, in such cases we find an energy is liberated. Energy is required to remove an electron in case of ionization potential or ionization energy. But whereas in the case of ionization, in the case of electron affinity, which we call as electron gain enthalpy, in such cases we find an energy is liberated or given out when an electron is added. So here again you can say like it's losing and gaining of electron. Now when you are training about ionization potential or ionization energy, in such case you are finding like how electron is given out. So to give out the electron we require energy, and that energy we are calling as ionization energy or ionization potential. In the same case, like when you go for electron affinity, in electron affinity we are trying to see that an electron is added, and during which when you are adding an electron, energy is given out. So energy is required and energy is given out. The both losing and gaining of character of electrons takes place, where you are trying to find an atom need to be stable and electrically neutral. So you can find these all the following properties, and these all following factors definitely gets effect in case of ionic bond formation. So in our today's class, children, we have done with your first part where with ionic bond formation, and we learn like what are the factors which affects the ionic bond formation, and where we basically in generally we define ionic bond formation as, we define ionic bond as just sharing of electrons by two dissimilar elements, one being a cation and one being an anion. So when we say about cations, those cations are highly electropositive in nature, like example metals. And when you go for anions, where we take examples as anions where they are found to be highly electronegative elements. And even we have learned the electron theory of valence and trying to find like how losing or gaining of electron takes place, and try to show an atom need to be stable by attaining its octet rule by getting 8 electrons in its valence shell or its outermost shell or on orbit. And in our next class we are going to go with the concept of covalent bond formation with sort of examples. So till then, visit to our website classroomtv.in for latest videos, materials, practice paper, each and every content and material you are going to get when you are logging to our website classroomtv.in. Until then, we will meet in our next class with the next concept, and keep watching Classroom TV.